Okay, we're going to have a look this time at what's called the difference of two cubes. We're going to factorize the difference of two cubes. But before we do that, let's just have a look at these numbers here again. So remember that, especially the cubed ones, but we know that 4 is equal to 2 squared, 9 is equal to 3 squared, 8 is 2 cubed. We got another cube down here, 27 is equal to 3 cubed. Let me see, 64 is 4 cubed. 125 is 5 cubed, and 216 is 6 cubed. And you could keep going with all of them. So very important numbers to remember. So let's have a look at what's called the difference of two cubes. So say we have something cubed minus something else cubed. Well, in order to factorize it, this is a difference because I have something minus something, and it's something cubed minus something cubed, so it's a difference of two cubes. In order to factorize that, I can rewrite that as a product, something by something. So it's just the x minus y multiplied by x squared plus xy plus xy plus y squared, where xy means x multiplied by y. Okay, or you might prefer to see it written like this. So if I've got something cubed minus something else cubed, so the first cubed minus the second cubed, it's just the first minus the second multiplied by the first squared plus the first times the second plus the second squared. So let's have a look at an example and it'll make a little bit more sense maybe. So we have to factorize p cubed minus 8. Well, you got to remember, let's have a look at this number 8. 8 is the same as 2 cubed. So instead of writing p cubed minus 8, I can write p cubed. That's the same as p cubed minus 2 cubed. Now if you look at that, well, we've got the difference. It's a difference because we're subtracting, and it's a difference of 2 cubes. So p cubed minus 2 cubed. So I can factorize that using the difference of two cubes method up here. So the first is p and the second is 2. So it's just going to be, in order to factorize it, the first cubed minus the second cubed, which I have here, is the first minus the second, so it's p minus 2 multiplied by the first squared, so p squared, plus this bit here says the first multiplied by the second. So the first multiplied by the second is p multiplied by 2, first and second, and then plus the second squared, so plus 2 squared. And that's it. I can tidy it up a little bit. I could guess that's p minus 2 multiplied by p squared plus p by 2 is 2p plus, and then 2 squared is 4. So I factorize it. I started off with this difference up here, and I factorize it. I've written it as a product, this multiplied by this. Let's have a look at another example. So we've got 125p cubed minus 8q cubed. So let's have a look at those two numbers first of all. 125 is the same as 5 cubed. There we go. And 8, was it? Yeah, 8q cubed. 8 is the same as 2 cubed. So instead of writing 125, I'm going to write 5 cubed. So that's the same as 5 cubed p cubed minus 8 is 2 cubed q cubed. So instead of writing, I haven't factorized it yet, I've just rewritten 125 in a different way and 8 in a different way. Instead of writing 5 cubed p cubed, I'm going to put the 5 and the p in brackets. So write 5p and put the cubed outside, and I'm going to write 2q in brackets. So 2q and put the cubed outside. And now if you look at what I have, I've got the difference, because I'm subtracting, so it's a difference, and it's a difference of 2 cubes. Something cubed, so the first is, whoops, there you go. The first is the 5p, so it is a difference because I've got something minus something, and it's a difference of 2 cubes because both of those somethings are cubed. The first is 5p and the second is 2q. So I can factorize it using this up here. The first cubed minus the second cubed, there we go, is the first minus the second. So that's equal to, the first is 5p, so it's 5p minus 2q. First minus second multiplied by the first squared. So I'm going to put it in brackets because I'm going to square it. So it's 5p squared. I didn't put this in brackets because there was only one thing when in the previous example, but here it's 5p all to be squared. So I'm going to, just two things. So I'm putting it in brackets. So first squared plus first multiplied by second. So plus first, so 5p multiplied by the second, which is 2q. So times 2q. Where we plus the second squared, so plus the second, which is 2q, I'm going to put that in brackets, squared. Now I can tidy it up. I can rewrite that as 5p minus 2q multiplied by, well, 5p squared is 5p times 5p. So 5 by 5 is 25, and p by p is p squared. 5p by 2q is 5 by 2 is 10pq, plus 2q by 2q, 2 by 2 is 4, q by q is q squared. And that's it. So again, I started off with this up here, a difference of 2 cubes, and I factorized it. I wrote it as a product, that times that. You can have a look at this example here. This is probably a bit easier actually. We got to notice that number 216, we got to recognize that as being 6 cubed. So another way to write x cubed minus 216 is x cubed minus 6 cubed. And now, once we write it like that, we notice, oh, we've got the difference of 2 cubes. So I can rewrite that as, well, the first is x, the second is y. So it's, if you go back to the difference of 2 cubes, how to factorize that. The difference of 2 cubes, first cubed minus second cubed is first minus second. So in this case, it's x minus 6 multiplied by the first squared. So the first squared is x squared plus the first by the second. So the first by the second, so plus x by 6 plus the second squared, so plus 6 squared. So I have x minus 6 multiplied by x squared. X by 6 is plus 6x plus 6 squared is 36. And that's it. Started off with a difference up here, and I factorized it. I wrote it as a product. This multiplied by this. So that leads us on to the third thing, which is, rather than have a difference of 2 cubes, now we have a sum of 2 cubes. So say if I want to factorize something like this, x cubed plus 27. Well, if we notice that 27 is the same as 3 cubed. So another way to write 27 would be, well, I rewrite that as x cubed plus 27 is 3 cubed. So that's x cubed plus 3 cubed. So in order to factorize that, well, I can use this formula up here. So I've got a sum this time. I'm adding. It's a sum. So it's x cubed plus y cubed is the same as, well, it's probably easier if we look at this one. If we have the first cubed plus the second cubed, it's the first plus the second times the first squared minus the first by the second plus the second squared. So in our case down here, the first is x and the second is 3. So we have first cubed plus second cubed is first plus second. So it's x plus 3 multiplied by first squared, so x squared, minus first times second, so minus first, which is x, times second, which is 3, plus second squared, so plus the second, which is 3, so plus 3 squared. And again, I can tidy that up by writing x plus 3 times x squared. X by 3 is minus 3x plus 3 squared, so plus 9. So I factorized again. Again, I started off with a sum up here, something plus something. And I noticed that 27 was actually 3 cubed, so I've got the sum of 2 cubes, and I factorized it. So I wrote it as something times something. I wrote it as a product, which is what factorizing is, just writing as a product. Okay, let's have a look at one more example. We've got 8x cubed plus 125. So think about the number 8. We've seen that already. And the number 8 is 2 cubed. So 8x cubed, instead of writing 8, I could write that as 2 cubed x cubed plus, and then the number 125 is the same as 5 cubed, so plus 5 cubed. So you can see why it's really important to remember these numbers, to just know them straight away. So when you see 125, you recognize it as 5 cubed. Otherwise you wouldn't see that this is the sum of 2 cubes. Now instead of writing 2 cubed x cubed, I'm going to put the 2x in brackets and put the cubed out here, and I have plus 5 cubed. So now I can see I've got something cubed, 2x, that's the first, plus 5 cubed. So again, the sum of 2 cubes, here's our formula here. First cubed plus second cubed is first plus second. So our first is 2x, so it's going to be 2x plus second, which is 5, multiplied by first squared. So it's 2x all to be squared. And because there's more than one thing, I'm going to put it in brackets. So minus first by second. So minus first, which is 2x, by second, which is 5, plus second squared, so plus the second is 5, so plus 5 squared. Again, I can tidy it up, so I can go, can't do anything with 2x plus 5, it is just that. So I can Okay, 2x squared is 2x by 2x, so 2 by 2 is 4, x by x is x squared. 5 by 2x, or 2x by 5, is minus 10x, plus 5 squared. 5 squared is 25. So again, started off with a sum, and it was a sum of 2. I noticed that this could be written as 2x all to be cubed, and 125 is the same as 5 cubed. So it's the sum of 2 cubes. And I was able to factorize it using the sum of 2 cubes formula, this one down here. And so factorizing just means, again, writing as a product, which I have down here. So hope that helped.